Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to do an example of using the ideal gas law and using stoichiometry at the same time. The prompt for this problem is going to look something like this. So if you want to take a screenshot of it really quick to look at it in a little bit more detail, you can. But here we go. Okay, it says calcium hydride, which is CaH2, is going to react with water to produce some calcium hydroxide and actually some hydrogen gas. Okay. And then the prompt says, how many grams of calcium hydride? So I'm going to put my underscore under the calcium hydride and put grams. This is where I need to end up by the end of the problem. Okay. And it continues to go on to talk about hydrogen gas. So I'm going to write that information underneath the hydrogen gas. It gives me a volume that's 145 liters. It gives me a pressure. It gives me a pressure of 825 torr, and it also gives me a temperature of 21 degrees Celsius. So I'll have to use this information to get all the way over here to calcium hydride. Okay. So what I'm going to do is I'm going to use the ideal gas law, which is PV equals nRT. I have the volume, check. I have the pressure, check. And I have the temperature, check. And the R is a constant, so I have that as well. So with that information, I can figure out the moles. Okay, so the moles, if I divide by RT on both sides, is going to be pressure times volume over RT. All I did was divide by RT on both sides. Okay, now I do have some issues here. Okay, the first issue that I have is that my pressure is in torr. So I'm going to convert the torr into ATM. And the way you do that is you take 825 torr and you convert the torr into ATM, and the ratio or the conversion factor is 760 to 1. Okay, so 825 divided by 760 will give me my ATM for this particular problem, and the ATM comes out to be 1.086 when I take 825 and divide it by 760. Okay, I have to get my temperature from degrees Celsius over into Kelvin. And the way I do that is by taking my degrees Celsius and adding 273. So 21 degrees plus 273, if I add that together, that equals 294. Okay, so now that I have my pressure in ATMs and my temperature in kelvins, I can continue using this ideal gas law in order to solve for the moles. So let's go ahead and plug everything in. The pressure is 1.086 ATM. The volume is 145 liters. The R, that's a number that I have my students memorize. Sometimes if you're taking an AP test or something like that, you have a reference sheet. And on the College Board test or the AP exam, they do give you a reference sheet that tells you that R is equal to 0.08206. And the units on that is atmosphere liters over mole Kelvin. And then the temperature, okay, is going to be 294 Kelvin. Now, the reason we had to switch over to ATM in Kelvin is because my R has ATM in Kelvin, and we need things to cancel out. So let's take a look at what cancels out. ATMs cancel out, liters cancel out, kelvins cancel out, and I'm left with this unit of moles. Okay, so in my calculator, I'm going to take 1.086 times 145, divide by 0.08206, divide by 294. Okay, and that will give you your moles. Okay, and the moles will come out to be 6.527. Well, 6.527 moles of what chemical? Okay, well, if we're talking about the volume, pressure, and temperature of hydrogen, when we use PV equals nRT, this is going to be moles of hydrogen. Okay, and I now need to figure out how to get moles of hydrogen over here to grams of calcium hydride. So I'm going to take that 6.527 moles of hydrogen, and I'm going to convert using my train tracks. I'm going to go from moles of hydrogen to moles of the chemical that I want to talk about, which is calcium hydride. And then I'm going to take those moles of calcium hydride and convert it to grams of calcium hydride. The mole to mole conversion is 2 to 1, 2 for the hydrogen, 1 for the calcium hydride. And when I add up the molar mass of 1 calcium and 2 hydrogens, that comes out to a molar mass of 42.1 grams per mole. So if I take that 6.527 moles of hydrogen, divide by 2, and times by 42.1, I'll get my answer of 137 grams of the calcium hydride. So 137 grams of calcium hydride would have to react in order to produce this volume, pressure, and temperature of hydrogen gas. Okay, and just to show you, the moles of hydrogen cancel out, the moles of calcium hydride cancels out, and I'm left with those units of grams of calcium hydride. If this information was helpful to you to understand how to use the ideal gas law mixed in with some stoichiometry, please give it a like and subscribe. Even add a comment will help the YouTube algorithm get this information out to other students that are interested in learning chemistry.